Okay, this is an algebra question, and it may seem kind of innocuous or not so difficult, but keep in mind that as the test goes on, the later you get into the test, typically the more difficult the questions are. So this may not have seemed like much, but there really is a lot going on. It's a review of number lines. Keep in mind that when you have number lines and inequalities, inequalities are the less than, greater than, less than, equal to, greater than, equal to symbols. When you combine those two together and you have a number line, you typically have an open point. So like if this is -4 on your number line, you would open that. If your solution set is everything greater than -4, you would draw an open circle around the -4, and it would be everything in that direction. So if it's less than, greater than, it doesn't include the actual number on the number line. Absolute value. This is the key of this question. Remember that absolute value symbol are the two large parallel lines, and whatever comes out of the absolute value must be positive. It has to do with distance on the number line, not the negative or not the negative value of it, but the distance. So if you have a number line with 0, so let's say they give you the absolute value of x greater than 5. Well, if you didn't have the absolute value symbols there, it would just be x greater than 5. So you would find 5 on your number line, and it would be all values not 5, but all values greater than 5 would be the solution set for that. But because we have absolute value, there's also another set of numbers that will answer this. If you go 5 in this direction, so that includes all numbers to the left of -5. If you put -6 between the absolute value, you get 6, and 6 is greater than 5. So the solution is all negative numbers that are less than -5, to the left of -5. And we're going to do more of this, but it's important that you understand absolute value and how it works with inequalities. And then what we just did right here, the absolute value of an inequality, what a solution set looks like. And really important with these is that you test your answer, because there can be a non-answer or a null set with absolute value. So let's just take a look at some of these and graph this. So x less than 10, if that's 0 and 10 on our number line, so x less than 10 would be all numbers on the number line that are to the left of 10. So these would go on forever. But because it's absolute value, we also have to put a stop right here. This is -10, and open that up. It doesn't include -10. So it would be everything between 10 and -10. Very similar to what we did up here. So let's take a look at this one. 5x greater than or equal to 15. So now you have to do a little bit of algebra and solve this first. And I want to show you how you end up doing these. You break it into two things. So if we have 5x greater than or equal to 15, first you can ignore the absolute value signs. It's just 5x greater than or equal to 15. So whatever comes out of this side, I'm not talking about the solution set, I'm just talking about the outcome set, we'll call it that. Whatever comes out of this left side has to be greater than or equal to 15. So if this is 0 and here is 15, we know that whatever comes out of this 5x side, this little function that we're going to perform over here, the result has to be greater than or equal to. So now we fill this point in because it includes 15, everything in that direction. But we also know that there's some other answer over on this side because we have this absolute value. And because we have absolute value, we know that there are some negative numbers that we can put in. If we get a negative value that is greater than or equal to 15, it will strip out the negative sign. So if the answer comes out to the left of negative 15, those will answer and make the statement true also. So that means you have to set up a second inequality, and that is 5x that represents this part right here. So it's less than negative 15. So we did two things. We switched this sign right here. We switched the inequality sign, the direction. In this case, it would be less than. There was an equal sign there too. And we switched that sign. So we started with 5x greater than or equal to 15. Now we have 5x less than or equal to negative 15. And you can see how we drew it on here so you could visualize that. So you have to solve both of those. When you have an inequality and an absolute value, you have to break it into two because you have two potential solution sets. It's one solution set, but two different places on the number line. And they typically will show up either as an open circle around the number if it's not equal to, or closed if it is equal to, greater than, less than, equal to. And then the solution will either go in opposite directions like this from those two numbers, or those two numbers will be the limits, and then everything will be in between. Those are typically the two ways, I think it's the only two ways that you'll see it. So let's take a look at this one. Now we've got even more going on. The absolute value of 5x plus 3 less than 13. So we know whatever will come out of this left side, if it's less than 13, it makes the inequality true. So if this is 0 and this is 13, anything to the left of 13 would be a true answer to this inequality, 5x plus 3 less than 13. And we know if we get a negative 13, it's actually everything up to negative 12.99999 up to 13 would also answer this. So we have negative 13 over here. And once it comes out of the absolute value symbols, then it would be everything. So let's solve this one and show you how that's done. So we start off with 5x plus 3 less than 13, and we can just solve this. 5x, we subtract 3 from both sides, less than 10, and then divide by 5. And since it's a positive 5, we don't have to do anything to the sign. 5 divided into 10 is 2. So there's part of our answer, x less than 2. And then we have to do the other side of it, and we change both signs. We change this and we change this. So we end up with 5x plus 3 change the direction of the sign, greater than negative 13. And then we do the algebra. So that would be 5x, subtract 3 from both sides, so negative 3, and negative 13 is negative 16. All right, so then we divide each side by 5, and it's a positive 5, so we don't have to worry about flipping the sign. And remember, flipping the sign for a negative would be true irrespective of this flipping that we did here. This is a separate issue. We don't have to because it's a positive. X greater than negative 16 fifths. And that's our answer. And negative 16 fifths is the same as 3 1/5. Negative 3 1/5. So now we have our two answers. X greater than this and x less than this. Just need a little more room here. This is our actual solution set. What we did first here was to show the results. If we run these numbers, any numbers between these two, it will give us this result right here of everything between, not including, negative 13 on the one side and 13 on the other. So the solution set would be graphed like this. Here's 0, and then on the right side it was x less than 2, so let's say that's 2. So that's open, and it's everything in this direction up to x equal negative 3 1/5. So let's just say that's negative 3.2 is the same as 3 1/5. And that's an open, and it's everything. So that would be the solution set. X is greater than negative 3.2, and x is less than 2. That's how you would write that. Okay? Oh, I wanted to show you to test this then. So our number line keeps going out here. If we pick a number to the left, let's say 4, it shouldn't work. So if we plug 4 into 5x plus 3, or excuse me, negative 4. Negative 4 times 5 would be negative 20, plus 3 would be negative 17. And negative 17 is not less than, well, the absolute value. 17 is not less than 13. So you can see that that worked. And then if we pick any number in between the negative 3.2 and the 2, that should work. So if we put 0 in to test it, the absolute value of 5 times 0, that's 0, plus 3, we get 3. The absolute value of 3 is 3. 3 is less than 13, so it works. All right, so let's answer the question now with all this in mind.